Hello everyone, this is the feedback video for the second week of the Erlang Functional Programming MOOC. I'm going to keep this short, not least because I'm recording it from abroad and it might be more difficult for me to get it uploaded onto YouTube. What we've been talking about this week are lists in Erlang, and some questions came up just about the general nature of lists in Erlang. I'll talk through those, and others about specific algorithms. First, about the generalities. There was some discussion about whether lists in Erlang are linked lists, are they singly linked lists, are they doubly linked lists, or are they something else? Well, the answer is they are simply linked lists. So that's possible to build in an entirely declarative way, because what we do in Erlang is have immutable data structures. We allocate new references when we build a new list, and in order to keep doubly linked lists in sync, to keep the links in place, we're a lot more complicated than simply using singly linked lists. So that's what we do. Another question came up about complexity of the list join algorithm, the plus. There was a question about whether it was more efficient to use the cons notation if you want to add an element to the front of a list, or to just write the element in square brackets and use plus. The answer is there isn't a difference there. On the other hand, if you write a list and join an element to the end with plus, the complexity of that is going to be linear in the length of the list on the left. In fact, plus, the way it's implemented, is dependent on, it does recursion on the list on the left, and so its complexity is dependent on recursion on the length of the list on the left. That means if we write a naive reverse algorithm where the recursive case says reverse of x cons x's is reverse of x's plus list with just x in it, that becomes quadratic. Hence the tail recursive reverse that you'll find in the Erlang lists library. What else? One question came up about how to deal with error cases. Stephen wrote quite a long and I think very nicely worded argument to say that the best thing to do, for example, for the maximum of an empty list, is to simply raise an exception to cause an error, and require whoever has called the list to handle it that way. Your code is then, the code that you're writing for Max is uncluttered, and the caller will have to respond. An alternative is to try to handle the case within the definition itself, so have some notional value, perhaps 0. That doesn't make too much sense here because 0 isn't an identity for the maximum operation. It would be fine using 0 if the list consisted of positive integers, but if there were negative numbers, if there were all negative numbers in the list, that could cause a problem. So that's not an ideal choice. The final choice is to return a type which is not a number, but might be more complicated. It might be a pair, say OK and a number, or a single atom, or something else signaling an error. It's perfectly possible to do that, that's fine. The problem with that is every client has to handle that. And if it's a recursion, then the definition itself is a client. So the recursive definition will have to handle that particular case. I wrote a comment on this in the MOOC, in the comments on the appropriate page, because in fact in the Max case there's a sort of hybrid solution which does work. But in general, the let it fail philosophy, even though it's perhaps intended more for the concurrent parts of Erlang, works equally well in the functional part. Finally, there was a question about the case expression versus using pattern matching at the function level. And I think the answer is, in many cases, in many examples, it's entirely right just to use the pattern matching that you get from function clauses, but there are situations where you want to use a case. Suppose you're calculating inside a function body and you've got some intermediate result and you want to switch on that result. You can use a case statement. If you didn't use a case statement, you'd have to define a function specifically to handle that switch, and that seems a bit over the top. I've experience of doing this when I programmed in a language called Miranda that didn't have a case statement. You finished up defining functions which were simply there in order to effect a case statement. So, good. Well done for getting so far. What we're going to look at next week is our more advanced examples where functions are used as data, and so on, and look at a larger case study. So you'll be able to put into effect what you've understood in the first week and just covered in the second, put that to effect in a larger example. Okay, that's it from me. Thanks very much.